In 1898, the shelf above the counter in every apothecary in the Western world held the exact same 5 things: a pale, fibrous bark stored in a glass jar with a wax seal, a fragrant resin pressed into dark amber blocks, a dense root capable of staining hands bright yellow, a rough, knotted rhizome traded at premium prices, and a twisted botanical fragment with small hooked claws along its surface. Most European customers had never seen the last one before. Healers were requesting it by name. These 5 botanical medicines had occupied those shelves for 5,000 years. Not on every shelf that mattered. In the Ebers Papyrus, the oldest surviving medical text written in Egypt 14 centuries before the Common Era, 2 of them appear as standard treatments for pain and fever. In the foundational text of Ayurvedic medicine compiled in ancient India, 2 others are classified together as the primary anti-inflammatory tools a physician could reach for. In the ancient Near East, the smoke of the amber resin rose in the temple twice daily, while identical extracts treated joint disease in surrounding empires. In southern Africa, the twisted hooked root had been treating systemic pain for so long that its use predates any written record. 5 traditions, no contact between them. 5 separate knowledge bases. The same independent conclusion reached on 5 different parts of the earth. Stay with this list, because the last plant is the one that will genuinely surprise you. It is the one that a modern European regulatory body formally approved for clinical use, while the pharmaceutical industry that invented aspirin was still pretending it did not exist. That story comes at the end of this shelf. Everything before it is what makes it possible. In 1899, 1 year after the apothecary shelf held all 5, a German pharmaceutical company named Bayer filed a patent for a new compound. They called it aspirin. The compound was acetyl salicylic acid. It was a synthesized, stabilized derivative of the exact same active molecule found in that pale bark. By the time the First World War ended, the original plant had been removed from the United States Pharmacopoeia. Within a generation, all 5 had followed it out the door. This is not the story of remedies that were tested and found wanting. This is the story of a business model that had no room for living organisms that could not be owned. The first plant on this shelf is also the oldest documented medicine in the Western world. White willow. The Ebers Papyrus lists willow preparations for pain and fever with the same matter-of-fact authority that a modern formulary uses for ibuprofen. Hippocrates prescribed a tea made from willow leaves and bark to women in labor for pain relief. The Cherokee people of the American Southeast called white willow toothache bark and used it for fevers, headaches, and muscle pain. Medieval European herbalists regarded it as the standard treatment for inflammatory pain. From Egypt to the American Southeast to a Benedictine herb garden in Germany, it was the same pale bark for the same suffering. The mechanism was finally identified in the 19th century. The active compound is salicin. When the body metabolizes it, salicin converts to salicylic acid. This acid inhibits the enzymes responsible for producing prostaglandins. Prostaglandins are the signaling molecules that drive pain and inflammation. The plant had been delivering that exact biochemical effect for 5 millennia before anyone knew the word prostaglandin existed. In 1899, biochemists acetylated that salicylic acid molecule. The new version was easier on the stomach lining. It was more stable. Crucially, it was patentable. The living plant was none of those 3 things. It could not be stabilized into a single uniform dose. It could not be patented. Any pharmacist could source it for pennies. Aspirin reached the market at a price point that made willow bark economically irrelevant. By 1905, willow bark prescriptions had collapsed. By 1920, the plant had been erased from the official lists. The patented molecule came directly from the plant. The plant was already there. The only thing that changed was who could profit from it. The second item on this shelf was considered so valuable in the ancient world that it was offered to a newborn king alongside gold. Most people have heard that detail their entire lives without asking what was actually in the jar. Boswellia. The milky white resin tapped from Boswellia trees has been traded across the ancient world for at least 3,000 years. The Ebers papyrus uses it for wound treatment. Egyptian mortuary texts describe its use in embalming preparations. In Ayurvedic medicine, it appears as shalaki, classified as a rasayana, a substance that preserves and restores tissue. The Talmud records its use as incense in the temple twice daily. The Canon of Medicine, written by Ibn Sina in the 11th century, classifies Boswellia as a primary treatment for joint disorders and respiratory complaints. The gift offered at a birth was not symbolic. It was medicine, given by people who understood exactly what they were carrying. Modern pharmaceutical research identified the primary active fraction in the 20th century. The compound is acetyl-11-keto-beta boswellic acid. Researchers call it AKBA. It is a selective inhibitor of the enzyme 5-lipoxygenase. This enzyme produces leukotrienes, a class of inflammatory signaling molecules distinct from the prostaglandins that aspirin targets. Boswellia operates on an anti-inflammatory pathway that standard painkillers do not touch. Clinical trials published in peer-reviewed rheumatology journals have found that Boswellia extract produces measurable reductions in joint pain and swelling in patients with osteoarthritis and rheumatoid arthritis. A European trial found it reduced structural damage markers in knee osteoarthritis. After 16 weeks, Boswellia was never replaced by a synthetic equivalent. There is no patentable pharmaceutical analogue of AKBA currently on the market. It disappeared from Western pharmacy shelves because a substance that cannot be patented cannot justify the billion-dollar regulatory pathway required to bring it back through modern drug approval systems. The resin is still being tapped from trees in Oman and India. The tree did not change, the economics did. The third root on this shelf is responsible for more pharmaceutical patent applications than almost any compound in the history of modern drug development, turmeric. In the Sanskrit medical texts of Ayurveda, the yellow root of curcuma longa is classified as a treatment for inflammation, wound healing, liver disorders, and digestive complaints. The Charaka Samhita lists it among the essential rasayana compounds. In traditional Chinese medicine, the same rhizome is classified as a blood mover and pain reliever. Chinese physicians used it for stagnation in the joints. Arab traders carried it along the spice routes into medieval Europe, where it appeared in European herbals under the name Indian saffron, and was prescribed for jaundice, liver complaints, and inflammatory swellings. The active compound is curcumin, the polyphenol responsible for that characteristic yellow color. Curcumin inhibits nuclear factor kappa B, one of the central signaling proteins in the inflammatory cascade. It also inhibits COX-2, the exact enzyme targeted by modern prescription anti-inflammatory drugs like celecoxib. The research base is extraordinary in volume. Over 15,000 published papers have examined curcumin. Clinical trials have shown measurable reductions in arthritis pain comparable to pharmaceutical anti-inflammatory drugs in direct head-to-head studies. Pharmaceutical companies have filed more than 120 patent applications on curcumin derivatives and delivery systems. Every single application exists because the compound works and cannot be patented in its natural form. The turmeric root itself belongs to no one and costs a few dollars a pound. The industry response to a compound it cannot own has been to spend decades attempting to synthesize a version it can. The natural version is still in the ground, still doing what it has always done, still turning the hands of the people who work with it bright yellow, the same shade it left on an Ayurvedic physician's hands 3,000 years ago. Notice the pattern forming across these first three plants: different continents, different languages, different cosmologies, and the same category of use described in identical terms: joint disease, inflammatory pain, the body turning against itself. 3 separate civilizations developed the vocabulary of anti-inflammatory medicine independently, and they kept reaching for the same shelf. That convergence is not an argument, it is data. What comes next is where the data gets uncomfortable for anyone with a patent portfolio. The 4th plant on this shelf is the only one that appears in the medical literature of every major ancient civilization simultaneously. Ginger. Confucius ate ginger with every meal. The Analects describe this as a daily practice he maintained into old age. The Greek physician Dioscorides classified it as a treatment for digestive disorders, stomach pain, and general warming of the body. Indian Ayurvedic texts classify dried ginger root as one of the 5 essential medicines a traveling physician must carry. Arab traders listed it alongside pepper and cinnamon as a commodity worth more by weight than most metals. Medieval European physicians included it in virtually every compound anti-inflammatory formula. Gingerols are the active compounds in the fresh root, and showgirls are the active compounds in the dried form. Both inhibit cyclooxygenase 2 and lipoxygenase, the same enzymatic pathways targeted by modern prescription anti-inflammatory drugs. They operate similarly to non-steroidal anti-inflammatory drugs, but without the gastrointestinal lining damage that prolonged pharmaceutical use produces. Randomized controlled trials comparing ginger extract to ibuprofen in patients with knee osteoarthritis have found comparable pain reduction. Multiple trials have confirmed that ginger reduces post-exercise muscle soreness to a statistically significant degree. For nausea specifically, the clinical evidence is among the strongest for any plant compound. Ginger has outperformed pharmaceutical anti-nausea drugs in several controlled trials for chemotherapy-induced nausea, post-surgical nausea, and pregnancy-related morning sickness. Ginger was never formally removed from pharmacy shelves in the way willow bark was. It was too cheap, too common, and too universally available to ever occupy the same commercial position as a proprietary medicine. Its obsolescence was not legislative. It was economic. When a living root that grows in every tropical climate can be had for almost nothing, it occupies no useful position in a system built around proprietary compounds. It simply stopped being thought of as medicine. Confucius was right all along. The 5th plant on this shelf is the one least likely to be in your kitchen, the least likely to appear in any history of Western medicine, and, as promised at the start of this, the most likely to make a pharmaceutical patent attorney deeply uncomfortable: devil's claw, Harpagophytum procumbens. The name comes from the hooked protrusions on the plant's fruit. These small curved claws attach to the feet of passing animals and are carried across the Kalahari. The San people of southern Africa have used the tuberous roots of this plant to treat pain, fever, and inflammatory joint conditions for more than 2,000 years. The first European record of its medical use comes from a German botanist named Wilhelm Burchell. He documented it in the early 19th century after observing its use among the Khoikhoi people. European herbalists who encountered it found it effective enough to include in German and South African botanical pharmacopoeias. The active compound is harpagoside. It is an iridoid glycoside that inhibits both COX-2 and nitric oxide synthase, producing anti-inflammatory and analgesic effects through mechanisms that modern pharmaceutical chemists took until the late 20th century to fully characterize. More than 50 clinical trials have examined devil's claw for musculoskeletal pain. A systematic review of those trials found evidence of significant reduction in low back pain and in hip and knee osteoarthritis. The German Commissionee, the regulatory body that evaluates traditional plant medicines in Germany, formally approved devil's claw for the treatment of degenerative musculoskeletal disorders. Read that carefully. A modern European regulatory body, the one that operates inside the same pharmaceutical framework that sidelined the other 4 plants on this shelf. It was formally approved. not as a supplement, not as a traditional remedy, but as a treatment for a specific clinical diagnosis, backed by sufficient evidence to meet the standards of a country whose pharmaceutical industry helped invent the modern drug approval system. In North America, it is sold as a dietary supplement when it can be found at all. The labeling does not mention the clinical trial evidence because the regulatory environment does not permit health claims on unpatentable compounds. The research did not fail. The business model simply has no use for it. 5 plants, 5 traditions, 5,000 years. When you lay them out together, the pattern is not subtle. All 5 inhibit the exact same class of enzymes, COX2, the lipoxygenase pathway, the prostaglandin and leukotriene signaling systems that drive the chronic low-grade inflammation, underlying arthritis, cardiovascular disease, and the daily pain that erodes the quality of millions of lives. The ancient world did not know the word COX2. Ayurvedic physicians did not have enzymatic assays. Cherokee healers did not run randomized controlled trials. Across 5 separate knowledge traditions, on 5 separate continents, over 5,000 years of direct human observation, they kept arriving at the same 5 plants for the same category of suffering. That is not coincidence. That is signal. In 1898, those 5 plants were on the shelf. In 1899, Bayer filed a patent. By 1950, the shelf had been completely cleared. The clinical record on all 5 is incomplete in the exact way the clinical record on any compound is incomplete when it cannot be owned. The human trials that exist for willow bark, Boswellia, ginger, and devil's claw are promising. For several applications, including ginger for nausea and devil's claw for low back pain, the evidence is highly robust. The turmeric data is voluminous and growing. What is missing across all 5 is the billion-dollar Phase 3 clinical trial infrastructure that only activates when a patent sits at the end of the runway. That machinery has been built repeatedly for synthetic analogues of these exact compounds. The botanical originals have not received the same investment. That is not a scientific judgment, it is an economic one. The aspirin molecule came from the willow tree. The AKBA that pharmaceutical researchers are still attempting to patent came from the Boswellia tree. The curcumin derivatives that companies are racing to stabilize came from a yellow root that Indian physicians prescribed 3,000 years ago. The gingerol analogues appearing in cancer pharmacology research came from a plant Confucius considered essential to daily life. The harpagoside scaffolds turning up in modern pain research came from a plant the San people of the Kalahari never stopped using. Through every era in which the Western world was busy forgetting it existed, the vault was not emptied because what was inside had stopped working. It was emptied because what was inside could not be sold at the profit margin that justified the lock. Subscribe to the Apothecary Vault. The shelves are being rebuilt, one plant at a time. The Apothecary Vault exists because the record of what was known does not disappear just because it becomes financially inconvenient. What was on that shelf in 1898 is still in the ground. The knowledge survived. What changed is who profits from the distance between you and it.